Every time you open a website, you type a name. But the internet has no idea what names mean. It only speaks in numbers. So in the half second before anything loads, a hidden system turns that name into a number by asking a chain of strangers you never see. It works hundreds of billions of times a day, and on the days it doesn't, half the internet simply vanishes. This is the system that makes the web usable by humans. It's called DNS, the Domain Name System, and it's the most important part of the internet that almost nobody thinks about. Here's the problem it solves. Every machine online is found by a number. An address like 142, 250, 190, 78. That's what traffic actually routes to. But nobody wants to type numbers. We want names. So DNS is the internet's translator. You hand it a name, it hands back the number. Think of a phone book for the whole planet, except no single book could hold every name, and it changes every second. So the answer is scattered across a chain of servers, and DNS knows how to walk it. Here's something almost nobody notices. Every website you visit begins with a question you never see. It happens the second you type a web address and hit enter. Because to you, this is a name, example.com. But to your computer, that name means nothing at all. So it turns it into one simple question. Who is example.com? And it hands that question to a helper called a resolver, whose whole job is to go and find the answer for you. But here's the catch. The resolver doesn't actually know the answer either. So where does it even begin? It goes straight to the top of the chain, to one of the most important machines on the internet, a root server. Now the root doesn't know where example.com lives, but it knows exactly who to ask next. So the resolver moves one level down to the .com servers. These are the machines responsible for every single name that ends in .com. And there are millions of them. But notice the pattern you're starting to see here. They don't hand over the address either. They simply point the resolver to the one server that truly owns example.com. And that finally brings us to the authoritative server. This is the one machine on the whole internet that actually knows the real address for example.com, because it's the one in charge of it. No more pointers. No more go ask someone else. This is where the answer really lives. So the authoritative server hands back the answer. A plain number, the IP address. It travels all the way back to your computer. And only now, after all of that, does your browser finally begin loading the page you asked for. So let's rewind and watch the whole thing at once. Your resolver, to the root, to .com, to the authoritative server, and back to you. 4 questions, 4 different machines, scattered across the planet, and all of it happened in the time it took you to blink. Do that every time, though, and the web feels slow, so the resolver remembers. Once it learns an answer, it keeps it for a while, a timer called the TTL, the time to live. Until that runs out, the next person gets the answer instantly. That caching is why DNS feels invisible. The first lookup walks the whole chain. The next million reuse it. Multiply that across every resolver on Earth, and a system that looks fragile on paper quietly answers hundreds of billions of times a day. Here's a wild fact for you. The entire internet's directory begins at just 13 machines. Well, 13 names. They're called root servers, lettered A through M, and every single lookup on Earth eventually traces back to one of them. So why stop at 13? It's not some grand design. It's a packet size limit from the 1980s. A DNS reply had to fit inside a single 512-byte message, and 13 addresses was the most you could cram in without breaking the rest of the internet. But here's the twist. Those 13 names aren't 13 machines. There's a trick called Anycast. One single address, answered by hundreds of identical servers scattered across the planet, over 1,900 of them, all quietly sharing the same name. So the directory looks fragile, 13 points that could fail, but it's really thousands of copies with no single one that matters. That redundancy is deliberate, because this whole system runs on something surprisingly delicate: trust and speed. Here's the delicate part. For most of its life, DNS never really checked who it was talking to. Imagine shouting a question into a crowded room. The resolver just believes whoever shouts back first. So, what if you're the one shouting? In 2008, a researcher named Dan Kaminsky asked exactly that question, and what he found was unsettling. The only thing guarding a DNS answer was one matching number, a 16-bit ID. That's just 65,536 possibilities. Guessable, floodable. So here's the attack. Blast the resolver with thousands of forged answers, each guessing that ID, racing the real reply. Land just one match, and the resolver caches your lie. Kaminsky's real insight made it worse. Don't fake one address. Hijack the authority for the whole domain. This is cache poisoning, the nightmare version of DNS. The name is spelled perfectly, the link looks completely real, and it still sends you straight to an attacker. The fix: unguessable randomness and cryptographically signed answers, a standard called DNSSEC. But here's the thing, you don't even need a clever attack to get lied to. You just need to join the wrong Wi-Fi. The moment you connect to a network, a hotel, an airport, a coffee shop, it gets to hand you a resolver. And your device, it just says, sure. So a malicious hotspot hands you a resolver it controls. You type your bank, your email, your work login, spelled exactly right, and it quietly answers with its own server, a perfect copy of the real page. The address bar never looks wrong. That's how real credentials get stolen. So DNS can be turned against you, but there's a scarier failure. When it doesn't lie, it just stops answering. Because if a name can't be resolved at all, the service might as well not exist. And we've watched that hit the biggest companies on Earth. October 21st, 2016. Twitter, Netflix, Spotify, Reddit, GitHub, PayPal, all unreachable across much of the US at once. The sites were running perfectly. Nobody could look up their addresses. They shared one DNS provider, a company called DIN. And what took DIN down wasn't a supercomputer. It was an army of hacked cameras. Malware called Mirai had quietly seized hundreds of thousands of cheap connected devices. Security cameras, home routers, baby monitors, all still using factory default passwords. On command, that swarm pointed at DIN's DNS all at once, burying it under a flood peaking near 1.2 terabits per second of junk. 3 waves over roughly 18 hours. The phone book for those sites was ripped out, not by breaking the sites, but by drowning the service that turns their names into numbers. And you don't even need an attacker. Sometimes a company deletes itself by accident. October 4th, 2021. Facebook, Instagram, and WhatsApp vanished completely. For about 7 hours. During routine maintenance, one command knocked out the connections in Facebook's own backbone, and a bug in the safety tool that should have caught it let it through. Their DNS servers were built to pull themselves off the internet the moment they lost touch with the data centers. So they did. They withdrew the routes to their own name servers, and instantly Facebook's names had no one to answer them. The company was still there, servers still running, but its name pointed to nothing, so to the world it had ceased to exist. Employees couldn't even badge into buildings, because that needed DNS too. That's the lesson in both stories. It doesn't matter how healthy your servers are. If the name can't resolve, there is no service. DNS isn't a convenience layer on top of the internet. It's the front door, and everything else is behind it, which is why hardening DNS matters so much. Remember DNSSEC? It signs each answer and lets your resolver verify the whole chain from the root down. So a forged reply fails the check instead of getting cached. It's the difference between trusting whoever shouts back and demanding a signature. And to stop the coffee shop hijack, your DNS questions are finally being encrypted, wrapped in HTTPS or TLS, the same protection your bank uses, so the network can carry your lookups without reading or rewriting them. The internet's most trusting system is learning not to trust so easily. So next time a page loads the instant you hit enter, remember what just happened. Before the padlock, before the login, before a single byte of the real site, Your computer asked a chain of strangers where to go and trusted the answer. That's the first thing that happens online. Every time. Hundreds of billions of times a day, the internet's first act is a question sent into the dark, to a system almost no one notices, until the day it goes quiet. If this changed how you see that little address bar, stick around. Now you know what happens in that half second. Most people never will.